Let us start lecture 22. So, we will continue our discussion on pourbaix diagram of nickel H2O system. Now, we have plotted nickel plus. This we have done calculations for simple nickel ion reduction to nickel, and then we have gotten another plot. This is type 1, and then another plot was like this with a slope 0.991, and here it was 0.11 volt, and here it was 0.25 volt with a minus sign. See, these two, type 1 and type 2, one of the type 2 reactions we have considered and then try to plot them. Now, we have told that this side is nickel and this side is nickel oxide, and here the reaction is nickel oxide plus 2 equal to Ni plus H2O, and this is Ni plus 2E equal to Ni. Now, let us see whether this side, right side, would be NiO. So, let us have a parallel line, and I am changing the pH. This is pH 1, this is pH 2, and the potential remains same, and this is the. So, we see that left side. Let us see that when it is pH 1, what is the hydrogen ion concentration. So, the pH 1 hydrogen ion concentration is this, let us say 1, and here H plus 2. Now, if we increase pH, concentration of H plus ion decreases, since pH is equal to negative log of H plus ion concentration. Now, for this reaction we can consider a reaction equilibrium constant, which is K. So, this K can be written as Ni, or in terms of concentration, so we can write this for this chemical reaction. Now, we see that K is constant. At this point, K is constant because we have attained equilibrium. Now, if we increase H plus ion concentration, then the system should go this way in order to maintain the reaction equilibrium constant. And if we decrease H plus ion concentration, the system should go this way. So, this is H plus ion concentration increasing, and on this side is decreasing. So, now if we increase pH, if we have this point, if we increase pH, so if we go to this point, I am reducing H plus ion concentration. So, here H plus ion concentration, if I try to have a relation between these two, so this should be this. And now, once we have this situation, then if I go from this point to this point, because at this point this equilibrium has set up. So, H plus ion concentration is decreasing. So, then of course, then reverse reaction. So, this reverse reaction should take place, reverse reaction should take place. So, that time nickel should get oxidized to form nickel oxide. So, that means this side definitely should then be NiO. Now, if I go to pH 1, then I see that H plus ion concentration is decreasing in comparison to, of course, this one. This was also having some pH level. So, this pH at this point is more than the pH at this point. So, at this point H plus ion concentration would be more than the H plus ion concentration what is there at this point. So, which is indicating the pH level at on the line of that E versus pH plot. So, once we see the hydrogen ion concentration is increasing, so in order to maintain this equilibrium constant, we have to go to the other side, that means this side. So, then this region definitely should be nickel and this region should definitely be NiO. Now, can we combine these two? So, definitely we can combine. Now, once we combine, let us see what situation is arising. So, this is E, this is pH. So, first draw dotted line and then we have this. So, now we can have two different colors. This is for type 1 reaction, this is for type 2 reaction. Now, for type 1 we know this is nickel side, this is nickel plus side, and for type 2 this is nickel side, this is nickel oxide side. Now, already we know if we consider this is the connection between these two, this connection point can be found out by simply solving two equations what we have already found out. One equation is for the type 1 is minus 0.25 plus 0.591 by 2 log of Ni plus plus. So, instead of activity we are writing in the form of Ni plus plus, and this is type 1 and E type 2 is equal to 0.11 minus 0.591 pH. So, these two equations if we solve for a particular nickel ion activity or concentration, we can get to know the potential as well as pH value. Remember, for that case we have to fix certain concentration of nickel ion or activity of nickel ion. Let us say we fix this nickel ion activity to be 10 to be 1, let us say. So, then this point would definitely would be minus 0.25. Now, that case this equation, this type 1 equation would simply be this. This is type 1, this is 2. So, then we can get at this point these two equations are equal. So, minus 2.5 equal to 0.11 minus 0.0591 pH. So, we get pH is equal to 2.37 is. So, the pH, this pH value is nothing but 2.37. If we solve this, we can definitely get to, sorry, I think we made a mistake in the calculation. So, it should be 0.25 plus 0.11 equal to divided by 0.0591 equal to 6.909. So, this value is 6.09 is the pH level, and potential, of course, it will be minus 0.25 if we consider activity to be 1. Now, we have to decide whether some of the parts of these two lines can be possible on the stability region of 3 species. Now, here we are having stability of Ni plus plus as well as Ni and NiO. Now, we know this region is this left to this is Ni, right to this is NiO, below this is Ni, above this is Ni plus plus. So, right to this NiO. Now, we see that in this zone we have no confusion, because here we are not having any Ni plus plus or NiO. But if we consider this zone, on top of this particular line, we see that Ni plus plus is stable, and below this line we should see Ni, but actually Ni plus plus stability line indicates that this region should be Ni plus plus. So, this particular line, we cannot definitely say that it should exist completely, because we do not know what is the relation between Ni plus plus and NiO. For that reason, we have to go for the type 3 reaction. And similarly, if we see this part, right top of it, it should be NiO, Ni plus plus, and bottom side it should be nickel. But already we know that on the right side of this line it should be NiO. So, nickel should not be present on top of this line. So, this particular region of the line, it should not exist, because that line indicating the equilibrium between Ni and Ni plus plus, but we see that in this zone we have, in this particular zone we have NiO after seeing the type 2 reaction. Finally, if we club it, if we see the clubbing, so it should be like this. So, we know this is Ni, this is NiO, this is Ni plus plus, but we have no idea what is going on here. In order to do that, we have to consider another reaction, which is type 3 type. It indicates equilibrium between Ni plus plus and NiO. Now, from this reaction we see that there is no involvement of electron if we do not have no involvement of electron. So, as per this triangle, we see only this region we can work with. See, if we work with that particular region, then we can find out K value. In order to find that, we have to find out a relation between, we know the relation between delta Z 0 and where K is the equilibrium constant for this reaction. So, delta G 0 would be again then summation of product minus summation of mu 0 of reactant. Now, we can see from this reaction mu 0 of product is this is the reaction equation we are getting. We have already known this value, this is 0, this is 0 point, this value becomes minus 257 29.8. This value is, it will become plus because this value is minus 48250. This would also become plus because the value of mu 0 H2O is 236 minus 236 964.2. So, 236 964.2. So, if we get this value, this becomes 69,484.4. So, K becomes, or rather RT ln K is equal to minus 69,484.2. We can do little bit of juggling with this K. So, instead of RT ln K, I can write 2.303 into 8.314 into 298 Kelvin. Since we are considering 25 degree Celsius, this is R value, universal gas constant, and log, since we are converting log ln to ln to a log. So, that is what this multiplication factor 2.303 is coming up. And then, so for this K is, if we consider in terms of concentration, NiO, or we can write, since we are writing in terms of activity, activity of NiO and activity of H plus, activity of Ni plus plus H2O. So, this 2 goes to 1 because these are pure substance, and now this equal to minus 69,484.2. So, log of minus log of equal to minus 69484.2 by 2.303 into 8.314. So, this value becomes, of course, into 298, it becomes minus 12.18. Therefore, this is nothing but minus, if I consider activity to be concentration of H plus ion, considering that the interaction parameter is 1 or activity coefficient is 1 rather. So, this becomes minus pH minus log of ANI plus plus equal to minus 12.18. So, I can simplify pH plus log of ANI plus plus equal to 12.18. This is the equation we are getting to indicate the equilibrium for this particular reaction. Now, once we know this equation, then we can also plot this on E versus pH for a particular concentration of or activity of Ni plus plus ion. So, this is pH axis, this is potential. Since here we are not having any potential value, definitely this particular reaction would be parallel to potential axis, because it is becoming potential independent reaction. So, it will be like a parallel line parallel to potential axis, and where of course, the activity of nickel plus plus ion is to be mentioned. Now, if we mention that, I think we made a small mistake here. So, there should be 2 here, 2 pH, because this power 2 would come. Now, if we consider this is to be 1, then this pH value at which this particular equation would be valid, pH would be 12.18 by 2 equal to 6.09. So, this pH would be 6.09. This is the point. Now, here we can definitely say which side is nickel plus plus and which side is nickel oxide, because this is reaction which is equilibrium between nickel plus plus and NiO. So, if we draw a parallel line to pH axis, this is the pH where the system has reached equilibrium. Now, if I go to pH level pH 1, the pH 1, the concentration of H plus ion is definitely more than the value what is there when the pH is 6.09, because if we have a decrease in pH value, the activity of H plus ion increases, or the concentration of H plus ion increases. So, that time, since I am increasing this H plus ion concentration, so in order to maintain the equilibrium constant, the system should go this way, reverse way. So, the Ni plus plus ion should form. So, this side is Ni plus plus. Now, if I go at this point, which is pH 2, where the hydrogen ion concentration should be definitely less than the pH at this point, which is the equilibrium pH. So, in order to maintain the equilibrium, since the hydrogen ion concentration has decreased at this point, so system should go forward direction in order to maintain the hydrogen ion concentration, and that is what the if it goes to forward direction, NiO should form. So, this side would be definitely NiO. Now, interestingly, we have 3 plots. One is type 1, another one is type 2, another one is type 3, which is this. This is pH, this is pH, and here we see that this is Ni, this is Ni plus plus, this is Ni, NiO, Ni plus plus, NiO. If activity of nickel plus plus equal to 1, this is 0.25, and that time this value goes to, as we have calculated before, 6.09 when activity is Ni plus plus equal to 1, and this is also 6.09 when activity of Ni plus plus equal to 1. Now, we can club these two. Now, here we can club these two lines. Since we have seen that this particular extended line should not exist because it is the region of NiO, but we are not sure whether this particular line would exist because we are not sure whether it is a nickel plus plus, it is a mixture of nickel plus plus and NiO zone. So, now if we try to solve equation this one and this one, let us see what happens, what is the point we can achieve. So, if we this is line and this line, rather I would say that this is nickel plus plus NiO Ni. Now, I would like to find out this point. So, we can definitely find this point by solving E equal to 0.11 minus 0.0591 pH and 2 pH plus log of activity of Ni plus plus equal to 12.18. And since we are considering this to be 1, so then 2 pH equal to 12.18. So, pH equal to 6.09. So, if I put this here, E is equal to volt. So, you see that this point the potential also becoming minus 0.25 volt, and here also it was minus 0.25 volt. The connection between this line and this line was this, and when I try to see the connection between this and this, so there also the same point we are getting, the same coordinate we are getting on E versus pH plot. So, we would get a plot like this. Now, we combine all three reactions, this is reaction 1. Now, we see that this reaction also should go through the same coordinate which is minus 0.25 and pH equal to 6.09, and also this line should also continue like this. This is 0.11, 0.25, 6.09. This is activity of Ni plus plus equal to 1, activity of Ni plus plus equal to 1. This side is nickel, nickel plus plus, nickel oxide. Now, interestingly, last time we saw that this particular portion of the line should not exist. We were not sure about this particular line. Now, once we get to this particular line for the type 3, we know the left of this line should be Ni plus plus. Then, if it is then on top of this, we should have Ni plus plus. So, this entire zone should be Ni plus plus. And what about this line? Now, we know below this line it is Ni, left to this particular line is Ni. So, this entire zone should be Ni. So, this portion should not exist. So, if I draw the final region, whatever is not able to exist, whatever line, that portion will draw with a dotted line. And then we can plot the regions Ni plus plus Ni, and this is E, this is pH volt. So, we see that we can distinctively specify the stability regions of 3 species, this species, this one and this one. So, in nickel H2O system, we have considered 3 simple reactions and then tried to see the stability regions in E versus pH plot. So, we will have more on this pourbaix diagram. We will stop here for the time being, and next class we will start with 4 important reactions which are pH as well as potential dependent. That involves, those involve no metal or metal ions, rather those involve oxygen, H plus, OH minus and H2O. Let us stop here. Thank you.